everything is connected right now to the CAST rule and to reference angles. So in A it says, given that cos of alpha is -4/5, according to the CAST rule, you would know that that has to be in quadrant 2 or in quadrant 3. And they want us to find the other ratios. So this is, again, if they're asking you to find the ratios, they want you to write what sine theta would equal, what cos theta would equal. The ratios are something over something. They're a fraction. It's different than solving for the actual angle. So, if I know it's in quadrant 2, in quadrant 3, I'm going to split it up. I'm going to draw a picture of an angle in quadrant 2. I'm going to draw my 4 quadrants, an angle in quadrant 3. I'm going to label a reference angle back to the nearest x-axis on both of them, and I can make a triangle with that reference angle. What do I know? I know that cos adjacent over hypotenuse, I can label this as 4, this as 5. And we can do a squared plus b squared equals c squared, unless, does anybody recognize it? It's a famous triangle. What's the other side?
3.
It's 3. So you can do a squared plus b squared equals c squared. But if you recognize the famous triangle, that this is the 3, 4, 5 triangle, you can just write it down. But of course, we could do, right, we know the hypotenuse. 25 minus 16 is 9. You could figure out it's 3 from a squared plus b squared equals c squared as well. Okay. So here, this is my angle theta, or this is my angle theta to the terminal arm. But I can use my reference angle. It says, figure out the other. Oh, sorry, I have a typo in this one. They don't have theta. I've got to take out a little eraser. It's not theta, and it's not a reference angle with theta this time, because it's using alpha as the, so this is my actual angle, alpha and alpha. You ever get that way? You get used to writing x's and y's and then change the letters on you and you still write x's and y's? Same thing happens with angles. We're used to using theta for angles, but this time they use alpha. So then my reference angle is alpha with a little r. My actual length angle is just an alpha. So here, in quadrant 2, if I want to find sine alpha and tan alpha, well, sine is opposite over hypotenuse, would be 3/5. And tan is adjacent, opposite over adjacent, but since it's in quadrant 2, it would be negative. And here in quadrant 3, sine is still going to be 3/5, but here it's negative. And here in quadrant 3, tan of alpha is still going to be 3/4, but here it's positive. And so even though there's only one value for cos alpha, because it could be in 2 different quadrants, it's possible that sine of alpha could be positive or negative 3/5, and tan of alpha can be positive or negative 3/4. So this is part A, and we can just continue underneath, but we're going to use the work that we have done already. We need to find the possible values for alpha. So what do we always need to do? we need to find the reference angle first. So if I was using that triangle, since I know all of the sides, I could use sine, cos, or tan. Probably what I would do in this situation is that I would use cos because the purple numbers are the ones that were given to me. Even though it's a 3, 4, 5 triangle and you can't really screw up the 3 at all. You could use sine or you could use tangent. It doesn't matter. But I can set up my cos one again. Make that note over and over again. For a reference angle, you're using the actual triangle. You're going back to grade 10 math and saying, I have a triangle. For my reference angle, it is adjacent over hypotenuse. Those are both positive values because I'm dealing with my triangle. And here, I can now go cos inverse of 4 divided by 5. 3 decimal places, 36.870. Okay, I'm going to write that extra step. And you don't have to write this step if you get good at this. And my memory is gone, 36.870. There's my reference angle. So looking at the picture, does it make sense here you would have to do 180 degrees minus your reference angle? And in this one, you're going to have to do 180 degrees plus your reference angle. Again, the pictures are really nice because they tell you exactly what you need to do to find your angle. Does it say to the nearest degree? It does. So that'll be 37. And so 180 minus 37, 143 degrees. And 180 plus 37, 217 degrees. So at this moment, ask yourself, am I getting the reference angle idea? Am I getting the cast rule idea? Before you go to the homework in the next 10 minutes, make sure you get to a point where you say, I get this reference angle thing. I get the idea of the cast rule. Then later tonight, sometime random in the evening, ask yourself, do I get the reference angle thing and do I get the cast rule thing? Because that's the key new thing to everything in grade 11 and grade 12 right now. Getting that strong will save you a ton of work in grade 12 when you get to grade 12 pre-calculus or grade 12 apply. All right, circle just question number 13.